Welcome back, guys. To anyone new here, my name is Clinton Vegas and I'm a mechanical engineering graduate based in Scotland. So in today's video we're going to be going over my time at RGU as a mechanical engineering student and looking at the course year by year. So I'll be looking at year 1, year 2, year 3, year 4 and your 5th year, which is your master's year. And what I'll be doing is I'll be looking at the modules and showing you some of the modules that I really enjoyed and some of the modules that I found a bit difficult and I needed a bit more work on as well. So I'll go through each year through this process, and hopefully you guys can get a better understanding of whether or not you want to join RGU, if someone's watching this video who's looking to apply to RGU, or if someone needs a bit more help in the coming years of some of the topics that you might want to pay a bit more attention to and some extra help that you might need. So without any further ado, let's get into the video and I'll show you on my screen some of the modules. So let's just get into the video. You can probably see the screen just now. So let me go through the first year modules and then we will move on. So starting off, we have Maths 1A. So this is split up into semesters. You have semester 1, you have semester 2. And in semester 1 you have Maths 1A, sorry. And in Maths 1A, really what would be beneficial for someone moving from secondary to university is to have an advanced higher. I think it really helps you with, it's kind of like the stepping stone to university module. So without that, I think it can get a bit more difficult, but it doesn't mean that you won't be able to do the subject. I think you'll need a bit more help. That's it. So let's just go into that and see what subjects we have in there. So within Maths 1A, we have solving equations. Again, that's just your algebraic equations. Then changing the subject, probably stuff you've seen in Nat 5 and even higher. Then powers, indices, you'll see in higher. Logarithms, you'll see in higher. Binomial theorem, you'll see in advanced higher. I don't think you'll see that in higher. Then we go on to trigonometry. Yes, you'll see in higher, but I think a lot of the harder stuff is in advanced higher, but trigonometry. And complex numbers, you'll see in advanced higher. So you can probably see that there's this trend of having these advanced higher modules there. Then we have differentiation, and again, as I mentioned, a lot of the stuff will be from advanced higher, not higher. And that's it. So differentiation, a lot of differentiation. And partial fractions, again, advanced higher module. And then you have your past papers down here. So Maths 1A, for someone, even for me, when I came from advanced higher to university, it was still a difficult subject to get into, but I put a lot of hours. I think for first year I put a lot of hours because I didn't want to do badly in my first year of university. Alright guys, and so going on to Maths 1B, so this will be in second semester, and again, power series lecture, you'll probably see in advanced higher, and I think it was still quite relatively new for us, someone coming from advanced higher. I think that was still a new topic to learn. Integration, advanced higher, again integration, a lot of integration. And matrices, advanced higher. I think there's a lot more harder matrices topics in there. Again, matrices. And statistics, advanced higher modules. So you can see that university level is a lot of the stuff you'll get from advanced higher, and I think it really, you need that in order to just slowly guide you into university. Maths out the way for first year. Then we have introduction to electrical engineering, and for me, someone who wasn't too much of a fan of electrical engineering at the start, was really a hard subject for me. You won't learn, I think you'll learn the basics of it in advanced higher physics, but a lot of it is still very new. So learning about magnetic circuits, still a very hard topic. It was new for me, coming from advanced higher. Electromagnetism, new again. Electrostatics, which is a new topic. And circuit analysis using Kirchhoff's law, really hard topic to go over, so I definitely have a look in that. Real voltages and currents, you kind of learn a lot of that in higher and advanced higher. Introduction to alternating current, you'll learn about it in advanced higher. Components of AC circuits, higher and advanced higher. Using J notation, oh my god, this was the hardest part for me, definitely. yeah, J notation stuff, which is to do with your complex numbers that you learn in maths as well in advanced higher. it comes into here. And that's it for introduction to electronics. There's a few courseworks that you have to do, which were actually very nerve-wracking. I went into that really scared because you had to set up a circuit and make sure it runs, make sure it works, and then speak about the circuit. What happens to the current if the voltage goes up, or within that circuit, or what happens to the capacitance and things like that. So I definitely pay a lot more attention to that module. And going through, I think there's, in the future years, you have electrical power, which it builds up on. Professional skills, again, I forgot about this one. Oh, this was engineering drawings. So what happens within this module is that you enter a class and they give you an engineering drawing, which you will probably be familiar if you did GraphCom or graphic communication. And to someone who hasn't done graphic communication, will be relatively hard, but I think you have a lot of support within that class to help you. You have lecturers in there that help you do the drawings and help you out with the drawings. So you have, the whole thing is engineering drawing. So you get given an engineering drawing, you get a certain amount of time to do it, and you get graded on how well you've done it. So you go in, week out, doing each drawing, and then communication program. So these are communication, so how to present. I think you get split up into groups and you have to present something. And yeah, I think they give you a topic within this module, this communication module. And again, this whole module is to do with professional skill, of how you can display some of your work to a client. And that's exactly what they did. They gave us a module and we'd have to present it to them and sell that idea to them. Then we have to do a reflective analysis on it. So that's professional skills out of the way. So is the product development module. And actually this was a really fun module. What we had to do was we had to design an ROV, a miniature ROV. I'll probably link a picture below of what ours looks like. And you had to do the gearing for it, you had to do the PCB manufacturer, your coding, and your remote control for it as well. So yeah, we did it as a workshop. I think first you go in, you do your PCB manufacturer, your electronics, your gearing, and so on, and then at the end of that 10-week week period, I think it was a little competition between you and your friends, right? Everyone in your year group, and you had a group of 4 people in your group doing this whole project, and then you'd compete against the rest of them. So what it was, we had a water tank in RGU, and we dropped our ROVs in. We had to go down, collect a weight, and bring it back up to the surface. So this is really showing you what the ROV technology that we use in today's world. And it's funny because I work for a subsea ROV company currently, so yeah, it's still very relevant, and it really did help me understand a lot about the ROV industry. Next one, we have statics and dynamics. A hard topic, I think, for some. We learned about stress and strain in physics, in advanced higher physics, but not as much detail as some of the stuff we went through in here. So stress and strain, tensile test, which is your Young's modulus of materials, your forces at a point, and pin jointed structures. Oh, these were interesting. So pin jointed structures are for kind of civil engineers when they do bridge designs or anything with loads of members that are joined in place. So yeah, that was that. So you can kind of see this mechanical engineering degree is very diverse, and you learn about electronics, and you learn about civil engineering, you learn about gearing. So there's a lot of stuff that you do learn. So kinematics of how things move in a snapshot, I guess. Friction, yeah, a lot of stuff that you'll learn in higher to advanced higher energy and power. And then some courseworks. So statics and dynamics lab courseworks. Again, really hard courseworks that we had. I can go through them with you. So the courseworks were based around, you had a little sample of a material, and you'd have to do a tensile test on it, pretty much taking it apart until you find its yield strength, right? To the point where it doesn't go back to its original shape. And you just have to do a report on that, telling you what point is the yield strength, at what point does it fracture, and so on. And yeah, and that was it. A relatively hard topic. I definitely put a lot more time and effort into this topic over here. Moving on, we have Introduction to Design, Materials and Manufacture. So this whole module actually talked us through what materials to use, why you would use a certain material over another, corrosion and things like that. Very like surface level stuff. A lot of stuff that I'm learning now in my current work, a lot more in depth, but this module really did help me understand what materials to use. So coming on to thermal fluids 1, definitely one of my hardest topics, but also your most enjoyable one. It's a weird one because you learn so much, but it's something that you haven't done in secondary school. So this was definitely one of my hardest topics, modules in university in first year, but definitely one of the most enjoyable ones because you go through your heat transfer, systems and properties, energy transfer by heat and work, and the first law of thermodynamics. So you're looking at a lot of the stuff is to do with fluids and how they travel through pipes and heat transfers and all that sort of stuff with it. So really cool module. So that's everything in first year. Introduction to Industrial Electronics. As I said, it's a continuation from that Introduction to Electrical Engineering. And again, one of those harder topics for me anyway. Power triangles, filters, diodes, Zener diodes, transistors, digital numbering systems, logic gates, op amps, sensors. So all these different modules that you learn in for certain like small modules, that's what you're getting a better idea of. So this whole topic looks at electronics in a component level, so how certain components work. And again, I think you have a coursework based on that as well. Oh, this was definitely by far the hardest one. So electrical power. A lot of people failed. A lot of my friends failed in this module and had to resit it in the summer. But again, it's that continuation from Introduction to Electronics, but so much harder. So much harder. You're dealing with fundamentals of phasors, complex algebra, which is your advanced higher and first year maths that you learn, AC power, AC network analysis, the ideal transformer, phase generation supply, definitely a hard module there, power rectification, electrical transformers, DC circuits, DC motors, induction motors. So again, this, as I said, your electrical engineering students are also within this module, so for them it's their continuation, and you're learning. I think you split up in third year where they do their more in-depth electrical engineering and then you do more in-depth mechanical. But yeah, that was definitely a hard one. Mechanical engineering design. What was this again? Oh, this was the engine rebuild. We actually had a Ford four-cylinder engine, and we had to take it apart and put it back together. Really fun, and you learn so much about engines. Like, I loved cars, but I hadn't ever taken an engine apart. So I think what RGU do give you is that hands-on experience, which I really, really enjoyed. Oh, we also had to do aerofoils. Oh my god, this was actually a really fun module. Now that I think about it, we had to design an aerofoil like from carbon fiber. So design it in CAD and then like in the software, and then actually make it ourselves. It was a really cool module, and we had to make it out of carbon fiber, and then we could take it home. So, yeah, it was really good. I didn't realize. So you actually learn how to carbon fiber something with like vacuum sealing and everything. No, really cool. And oh my god, now that I think about it, there was so many things in this module that we did a whole wishbone analysis calculation thing for this. So we had a car which was going around a bend, and we had to calculate exactly the design of this wishbone and the damping system within it, so that the car wouldn't buckle when it goes around the corner and so on. Yeah, really, really cool stuff actually. Yeah, very hands-on module this. Mechanics of solids, another tough course to go through. New stuff, so you're looking at material properties in a lot more detail, looking at it down to its like microscopic level. Then we have thermal fluids 2, again another really hard module to because yeah, again, it's new and you're just continuing on. Do you know what this kind of reminds me of? Thermal fluids 2 reminds me of like differentiation or integration, where yes, you learn the basics, then you go on to a tiny bit more and you learn a bit more about it, and you keep developing this. And I think you do thermal fluids right up to like 4th year or something. So yeah, introduction to fluid static Bernoulli's equation, flow types, continuity equation, flow system, and flow measuring devices. So there you go. Those are all your modules for this year. Mechanical Engineering Design 1. What are we doing here? MATLAB. Oh, so this was your first year Mechanical Engineering Design. And there's a lot of MATLAB involved in here, which is kind of like I'd say like a mathematical coding software. There's a coursework on it, which was actually quite difficult. You're sitting in a class with everyone else, and they give you a problem on the board, and you have to come up with the code for it. And you get a bit of help here and there, but overall it comes down to you writing that code. So you need to know about the arithmetic, variables, number formats, and so on. So yeah, MATLAB coursework 1, resets, and so on. Oh, then we did SolidWorks. You learn about SolidWorks here, extruded cuts, and so on, and revolves, and all that sort of stuff. Assemblies. Yeah, so you learn about SolidWorks, and again, you're given you're sitting in the class, you get a model on the screen, and you have to design it. Yeah, no, really cool, really cool. No, I really enjoyed that actually. The hands-on stuff was really really good. I actually really enjoyed those. That's mechanical. In Mathematics 2, again, continuation from Mathematics 1, and you're looking at MathCAD. So you use another software here, which is MathCAD. So what MathCAD really is rather than writing stuff by hand and using a calculator, you type your equations in a math sheet and it does it by itself. So it's an automated calculator embedded software. It's pretty cool. So then we have first and second order differential equations, separation of variables, integrating factors, homogeneous and non-homogeneous, and mass spring damper systems, Laplace transforms, suppressed and delayed functions, yeah, partial differential equations, Fourier series, definitely a harder topic over here. Fourier series and Laplace transforms were definitely more difficult out of these. Eigenvalues. Do you know what? It's weird because I use eigenvalues to this day to do some analysis. Like I did an eigenvalue buckling analysis for pressure vessels in the job that I am at the moment. So yeah, it's still very relevant, all the stuff that you learn here. Yeah, really, I enjoyed maths. The thing is, I tutor maths for like kids in hires and in advanced hires now. So I still really enjoy the whole topic. So pay a lot more attention to that. Renewable energy systems. This is the worst exam I ever did in university. I think I ended up getting a C for it. The thing is, I really enjoyed the topic, the module itself, but the exam was really hard. It was for mechanical engineering students, we're good at like solving equations and all that sort of stuff. But this was a written exam. It was like, why is renewable energy, like, why would you have this many wind farms here and this and so on? And it was a written exam, and depending on how you wrote that answer, you'd get the marks for it. And my English skill isn't the best, so I didn't do too well. But you'll learn about wind farms. I think that one of the courseworks is you get a bit of land and you have to decide what angle to have the wind farms facing at, and how many wind turbines you need for it. Really cool module. And you learn about yeah, you learn about electricity generation costs, levelized cost of electricity, and solar power, hydropower, a lot of different, yeah, marine energy, solar energy, and biomass. And there was actually no, it wasn't for this, but yeah, so it's marine energy. We learn about solar energy, wind power, and so on. So integration of renewables. Yeah, really cool topic, and again, very relevant to this day, right? We have our group project, which was in third year. So with this group project, we had to design one of these, like a land yacht. However, ours wasn't a land yacht because I think they moved away from Balmedi, but ours was pretty much a go-kart. We had to pedal up and down a hill. First of all, ours didn't do too well. Our suspension system broke on that day, and yeah, we just didn't we didn't move anywhere. But overall, it was actually really fun project. I'll attach some pictures down below of some of the pictures on that day. But really, really fun project because you could have any design you wanted, right? And you'd have to make it. So you need to understand, is it possible to manufacture something? No matter how amazing your design is, can you manufacture it? If you can't manufacture it, then that design is hopeless. So it's this iterative process of going back and forth with your design and seeing how you can implement it and how you can make it cost effective. And they gave us a budget for this. They gave us welding equipment. They gave us all these different things to make this go-kart. Really cool. So you do this over, I think, semester 1 and semester 2. Next is industrial plant. A really hard topic, I'd say. So first, convection of heat transfer, and this actually moves on to what you do in 4th year as well. So centrifugal pumps, the Pelton wheel, scaling laws, centrifugal pumps, system curve and pump theory, flow and losses in pumps. And yeah, overall it's a lot to do with pump analysis in industrial plants, whether that's being offshore, that's still an industrial plant, whether that's being onshore within refineries and all that sort of stuff. So yeah, you use pumps quite a lot, so understanding how they work, what the losses are, a cool topic. And pre-project industrial placement. Oh, yeah, I forgot. So I did the fast track course, and this is kind of like a 3rd year going into 4th year summer, where you do an industrial placement. And it was a bit weird here because I took a year out of university just before I went into 4th year. I went and worked down for a turbocharger company called Cummins Turbo Technologies, and yeah, I took a year over there just to see what it's like working in an environment, get a bit of, like how I can implement the stuff I learned in university into that real job. So really cool opportunity, and I wish a lot of students could do that, go through a placement, and you gain so much more. And when you come back and when you apply for jobs, you obviously have that placement experience, which can really go quite far away. So I did a placement, took a year out, came back, and while I was there, I actually did my pre-project industrial placement. So I think it's 10 weeks that you have to do, and you have to record each and every day of what you're doing. Then you have to give a presentation at the end of it of what some of the work that you did there, and you have to put together a portfolio of all your work. Like, how did you accomplish the communication module? Like, how did you show your communication? Or how did you show your technical skills? What technical work did you do? What staff relation work did you do? How did you communicate with staff? So you have to have this massive pre-project proposal. And let me show you actually my one. Just to give you an idea what this pre-project proposal looks like. It's a folder like this. And everything inside here that you can probably see, right? Let me just open that up here. And so let me just open that up here, and you can see that you have to like label them with these things over here and go through it, each and every one, and you have to like color code it and everything. It's all about showing your work and your presentational skills and making it very clear. So you can probably see, like, I color coded it with different colors for each modules over the summer. So coming in then, after you finished 3rd year, I took that year out. I came back and I had some summer modules that I had to do. So before going into 4th year, if you're doing the fast track course, you have to do a few modules during summer, and that equates to kind of like your 5th year at university. I'll explain this in a bit. But in that summer, we had to complete these modules, which was social corporate responsibility, socially responsible management, and principles of asset management. So these 2 modules are over the summer, along with your pre-project industrial placement. So you have to do these 3 modules over the summer. Responsible management is to do with your governance, your construction of risk, regulations, supply chain management, introduction to local content. A lot to do with your governance of your company and how they look out for their local communities. That's really what that's about. Then your principles of asset management is how a business manages its assets, whether it's leadership, change, introduction to whole life costing, introduction to asset management,
asset management process, measuring asset management performance, non-financial factors, risk management, risk analysis, and so on. And the coursework for these are like Excel spreadsheets that you have to kind of complete, like sensitivity analysis and workshop examples and stuff like that. And then you have to write a coursework on a company and how they manage their assets and how you can better manage their assets. And for the social corporate responsibility, you had to actually take a company that had done something bad, whether that's BP, Shell, or whatever it is with like the oil leaks, and you had to write of how they overcame this disaster and how they improved their social corporate responsibility in the future, right? So that's really what that coursework was about. Going into fourth year then, and in fourth year, these were my modules. We had Energy Analysis 2, again, continuation from Energy Analysis 1, a lot to do with now, which was your FEA analysis. So you use softwares like ANSYS to conduct a lot of your experiments. Then we went into introduction of reliability, probability of something breaking, load strength interference, repairable system. So this is really for, say for instance, you're working in a manufacturing facility or a production facility. How do you reduce the risk of something breaking? So yeah, it's very much someone who's working in that manufacturing engineering role. Markov analysis. Then we have mechanical vibration. Modeling things in degrees of freedoms, Lagrange equations, free vibrations, so how things move, and how do we suppress the vibration of particular equipment. So yeah, that's that whole topic there. Then compound cylindrical components. Again, this was like analysis based on SolidWorks. Yeah, this was alright. I didn't enjoy it too much, this module. Controls and instrumentation. Oh my god, this was a hard one. This is kind of continuation from your electrical engineering. And yeah, very electrical engineering focused. So transients and steady state response. The hardest one, let me just go over the hardest one. Root locus. Definitely one of the hardest ones out from all of that. It's like a two-page working that you have to do for this. Absolutely crazy. And then instrumentations, so flow meters, signals and noise, intrinsic safety. Yeah, very electrical based topic. Then your MEng individual project. So this is your dissertation really. And within this, I think just before you go into fourth year, you get given a list of different topics and you have to pick one out of them, whether that's, literally there were some crazy ideas in there, how to improve the energy efficiency of a gym, right? And yeah, various topics that you can choose. And you can actually make your, you can submit your own idea as well. Like if it's something that you want to improve or something that you're quite interested in, you can submit that own idea and give the reasons why it would be a good idea for your individual project. However, if you're doing the fast track course, normally you tend to do a dissertation topic based on something from that company. And in my case, it was to do with the turbochargers and something I had invented when I was there. So I just worked on that throughout the whole year. And yeah, you have to do your dissertation topic, and at the end of it, you present it, you submit your paper, and you get a grade and stuff for it. So there was a lot of work that goes into your individual project, and you work through this continuously through fourth year, semester 1 and semester 2. Then on top of that, you have plant performance, which is another topic. So plant performance, we go through compressible flow, which was actually an amazing topic. I really enjoyed this one. So compressible flow, we looked into like fighter jets, right? And how they break the sound barrier. And you learn about how they achieve that and how the engines achieve that. So really cool topic. Numerical methods in heat transfer. You have to do FEA analysis on this. So FEA analysis, which is your ANSYS software, of how heat travels and how you use software to better mimic that result in real life. Then combustion, we look at I think this was to do with adiabatic. Yeah, this is combustion in plants, like in a like an offshore plant or refining plant and stuff like that. IC engines, your internal combustion engines. Really cool topic actually. You look at how engines work in a lot more detail. Fuel cell, and fuel cells are a lot more prevalent nowadays, especially with your hydrogen fuel cells and all that sort of stuff. So you look at those in a lot more detail, how they create, how they change like chemical energy to electrical energy. Yeah, no, a really cool topic. I actually really enjoyed this one as well. Failure analysis. Again, this is going on from your mechanics of solids in a way. So looking at fracture, creep and stress relaxation, theories of failure, ultrasonic testing. This is to do with your non-destructive testing, and very important if you're going into a field like this, like especially with offshore. There's a lot of NDT testing that you need to carry out to make sure that parts can withstand and they don't fail. And especially now with wind turbines, there's a lot of NDT testing that goes on, especially with drones and things like that. So yeah, no, really cool. Condition monitoring systems and all that sort of stuff. So yeah, really relevant topic. System engineering. So within system engineering, you have NDT again, your power transmission with your cars, like gearing, pressure vessels, and process piping. So if you were to be a process engineer or a piping engineer, especially, not process engineer, that's chemical engineer. So if you were to work with pressure vessels and piping, this is a really important topic, and I actually had an interview for a role like this, and I used some of my modules from there. And you learn about, I think one of the questions my interviewer asked me was, what calculations do you carry out? And it just came to me, hoop stress analysis. So really important to go over your notes again, even once you finish university. Power transmissions, as I said, gearboxes and so on. And as I was saying, RGU is very relevant to the stuff that you do nowadays. And yeah, you can probably see that with these fourth year modules. Safety, risk, and reliability. I don't want to go through too much of this, but it's looking at safety in a lot more detail of calculation based, right? So FMA is more written based, but then you have your system reliability, redundant systems, cut and set time methods, complex system reliability, and all that sort of stuff. And how do we prevent disasters from occurring? Engineering analysis 3, structural non-linearity, high order elements. Again, you do a lot of analysis work using ANSYS. And this was, now that I think about it, was this one of my fast track course? And what this fast track course really is that you do a module, but just after you finish, you do some modules during the summer, just after you finish third year and you're going into fourth year. So you do some modules there. You complete your fourth year, and just when you finish fourth year, you do summer modules there. And those two modules, kind of like your semester 1 and your semester 2, join together to make you your fifth year, complete fifth year. So you finish your degree kind of 6 months before. Really, that's what that is. And the modules that I carried out for my second semester fast track course was Engineering Analysis 3, Quality Improvement and Statistical Process Control, and what was the last one? It was just my post-project placement. So I had to get another placement somewhere else and do a report for that. So the modules that we cover in my second semester of my fast track course is Engineering Analysis 3, a lot to do with FE analysis, and this is when like the pandemic hit and we're all working from our homes, and I had to download the ANSYS software on my computer, and it was relatively slow. I did upgrade just before, so I was quite lucky, but for a lot of people it's quite a slow software to run. So you do a lot of your analysis work here, and then you have to write a coursework based on the analysis work that you do. And that's it. So there's no really an exam for that in Engineering Analysis 3, it's just coursework based. However, for quality improvement and statistical process control is you have to do an exam at the end of it. So looking at how do we control the quality of products as they go out from a manufacturer, and how do we conduct experiments for it. How do we sample test things to make sure that the quality that's going out is to the quality we want, and how do we just really stop errors from happening. So that's what that module was about. Not too much actually. If anything, the engineering analysis 3 was a lot more fun than the other one. And then on top of that, you still have to do your post project. Again, as I showed you the portfolio, you have to do another one for your post project with a company. And that's it. So after that, that's you kind of finished. And if you get all your grades, you'd either finish with a master's in engineering, or you can stop in 4th year and get your bachelor's in engineering.